What is up, everybody, and welcome back to another Year 6 lesson. Today we are on Unit 5 and we are going to be looking at ratio, proportions and statistics. So let's strap in and see what we're going to learn. We're going to learn all about how to find the mean of a set of numbers before looking at the mean, the mode, the median and the range of a group of numbers. Then we're going to have a little introduction to ratio before looking at equivalent ratios and how to simplify a ratio. That should all lead us to be able to solve how to find missing ratios. And then finally, we're going to finish with looking at how to find the percent of a number. So let's waste no time and let's jump into the first part of our lesson, finding the mean of a set of numbers. Okay, so the mean or the average of a set of numbers. What does it mean? Let's just have a quick look at this. This is a set of numbers. We have 5, 3 and 4. If we were to find the mean, what it means is we are finding the average between all three of them. So how do we do that? Well, there's a very simple trick. What we have to do is add up all the numbers and then divide by the amount of numbers. Let's see what that looks like with question 1. So question 1 has numbers 5, 6, 9, 2 and 3. So let's add them up. So we have mean equals, we have 5 plus 6 plus 9 plus 2 plus 3 divided by how many we have? We have 1, 2, 3, 4, 5. So let's add them up. 5 and 6 is 11, plus 9 is 20, plus 2 is 22, plus 3, 25. So we have 25 over 5. 25 over 5 looks like a fraction, but it's just division like we know. 25 divided by 5 equals 5. So for this first question, our mean is 5. The average of these 5 numbers is 5. Let's do the same thing now to question 2. So we have mean equals, and then we have much bigger numbers now that are going to be a bit harder to add up in our heads. And then we're going to divide it by how many there are, and there's 1, 2, 3, 4, 5 again. So I'll put it over 5. And I've just done some quick maths and learnt that these top numbers equal 180 over 5. So therefore, how many 5s are in 180? We have 36. So the mean, the average of this set of numbers is 36. Easy. So before we go, let's think about things to remember. The mean is effectively saying the average. To do it, we need to add up all the numbers in our list, and then we're going to divide by the amount of numbers that we have. Here are 2 questions for you to have a little go at. Press pause on the video, take your time, and I'm going to see you in a minute. Okay, so now we've learned how to find the mean of a set of numbers. Let's look at the full group, the mean, the mode, the median, and the range. Let's go. Okay, so the first thing we need to understand is, what do these words actually mean? So, talking of mean, the mean is the average of the set of numbers. The mode is the one that comes up the most frequent. The median is the one that sits in the middle of the set when we put them in a sequence. And the range is the spread, which means what amount does our set of numbers cover. So let's dive in and see what that looks like with this set of numbers. So the mean means the average. So to find the mean, what we have to do is we get the sum of all the numbers and we divide it by the quantity of how many there are. So in this case, we would add 43 to 24, 54, 70, 80, 34 and 36, 36 to 29, and we would get a total of 414. Now I just used my calculator, but if you wanted to, you could use column addition if you didn't have a calculator handy. So therefore my mean equals 414 divided by the quantity. And what is my quantity? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers altogether. Therefore, mean equals 414 over 9. And 414 divided by 9 equals 46. So the average of all of these numbers here is 46. Okay, how about the mode? So the mode refers to which number comes up the most frequently in the data set. And we can see by just glancing at these numbers here that there's only one set of numbers that comes up twice. We have a 36 and another 36. Therefore, as this is the only number that comes up twice, the mode must equal 36. Okay, and how about the median then? So we said the median is the middle number. So the first thing we have to do is we have to write these numbers in a sequence, starting with 24 being the smallest, then 29, then we have a 34, then we have two 36s,
Then we have a 43, 54, 70, and finally 88. And the way I like to get to the middle is just by simply knocking off the edges until I arrive at the middle. So I can knock off 24 and 88, 29 and 70, 34 and 54, 36 and 43, leaves me one number in the middle, 36. So my median is 36. Now just incidentally, let's imagine we had an even set of numbers, because we have 9 here, but let's imagine we had 10. Therefore we would end up with two numbers in the middle. We could end up with a 36 and a 40. And the way that we would find the median then, we would simply add these two numbers together and divide by 2. 36 add 40 is 76, divided by 2 is 38. So for this example, the median would be 38. But in our data set, our median is 36. And finally, the range. The range refers to the amount of numbers that our data set ranges from. So the way we're going to do that is we're going to get our smallest number, which is 24, and our largest number, which is 88. So this would show the range that it goes between. This is the smallest number and the largest number, but the range refers to what value this is. So a way that we can find this gap, we could do 88 subtract 24 equals 64. So the range between my smallest and my largest number is 64. Therefore my range is 64. And there you go, that is finding the mean, the mode, the median, and the range of a set of numbers. Let's just think about what to remember. Our mean basically means the average, and we do that by getting the sum of the numbers by adding them all together and dividing it by the quantity of numbers. Mode means the most, which number comes up the most, and we can simply look at our numbers, tally them up if we need to. The median is the middle number, and we have to put them in a sequence from smallest to largest and find out which number's in the middle. If we have an even number, and therefore two middle numbers, we have to find the average of those two numbers. Finally, the range is the spread, so we find the smallest and the largest number and we find out the difference between the two. Now it's your turn. Have a go at finding the mean, mode, median and range of this new set of numbers. Put your answers in the comment section. I'm going to try and mark every single one.
Right, now let's start our little section on ratios and just have a quick introduction to what a ratio is. Let's go.
So in this lesson we're going to learn about what a ratio is, how we can show a ratio, and we're going to look at some word problems that involve ratio. So let's have a look at this first example together, and this says the ratio of apples to oranges. Now the order that a ratio question is given to you is very important because we're looking at the ratio of apples to oranges. And there's a number of different ways that we can show this in a ratio. Our first one, we're going to simply just count our apples, and we've got 1, 2, 3, 4, 5, 6, 7. So we have 7 apples to how many oranges? 1, 2, 3, 4, 5. So we have 7 to 5. So our ratio is 7 apples to 5 oranges. That's the first way of showing it. Then we could show it using the colon, which is the symbol for ratio. So we could show 7 colon 5. That's another way of showing it. That's the most common way of showing it. But then we could also show it in a fraction because ratios and fractions are very closely linked. So we could also show it with being 7 over 5. We have 7 apples to every 5 oranges. Okay, so let's have a look at this second example. This one says the ratio of boys to girls. So again, I'm going to look at the 3 different ways that I can show this. And I can see that I have 1, 2, 3, 4 boys. So I have 4 to how many girls? 1, 2, 3. So I could show it 4 to 3, or I could put 4 colon 3, or I could write 4 over 3. But at this point, I'd like to just show you something. Now, if I get rid of one of these girls, boom, just like that, now we have a totally different ratio. Now, of course, we have 4 to 2, 4, 2, or 4 over 2. But what we can actually see is that we can simplify this ratio very much in the same way as simplifying a fraction. And if we were to look at this fraction, this 4 over 2, we might be able to see that actually this just shows that for every 4 I have 2 girls. So for every 4 boys I have 2 girls. But what we might also be able to see is that we have, for every 2 boys, we have 1 girl. And again, for this second group, every 2 boys, I have 1 girl. So my simplified ratio could be 2 over 1. And again, I could show that with 2 to 1 or 2 to 1, just like that. And this would be the simplified version of the ratio. And just like fractions, we always want to show the ratio in its simplest form. Okay, let's have a look at a word problem then. This says John has 4 blue socks, 9 red socks, and 2 black socks. First question says, what is the ratio of black socks to blue socks? So it's asking you for black socks. So let's put a line underneath the black socks to blue socks. And we have 4 blue socks. So I've got to be very careful and follow what the question said. And it said the amount of black socks to blue socks. So I have 2 black socks to every 4 blue socks. So my ratio is 2 to 4. Now what you might see is if we make this into our fraction, 2 to 4, you might see that this can actually be simplified. I can divide by 2, and I can divide by 2, and I'd get 1 over 2. So my ratio is actually 1 to 2. Then my second question says, what is the ratio of red socks to the rest of the socks? So this is a 2-step problem. So how many red socks do we have first of all? Well, I have 9 red socks, so I know that I'm going to be starting with 9 to something, and then I need to actually calculate my blue socks and my black socks, and 2 at 4 is 6. So my ratio is 9 to 6. But again, I think I can simplify this. And just following the rules of simplifying, whatever I do to one number, I must do to the other, and I have to use multiplication or division. If you're not too confident on simplifying fractions or simplifying in general, check out my simplifying video, that's going to really help you out. But I can see that we can divide 9 by 3, and I can also divide 6 by 3, and 9 divided by 3 equals 3, and 6 divided by 3 equals 2. So my simplified ratio is 3 to 2. Okay, and there you go. That is an introduction to ratio and what ratio looks like, and looking at a word problem.
Okay, so now we know what a ratio is, let's look at equivalent ratios. This is a very useful little skill so that we can manipulate ratios to look however we want them to for later problems. Let's go.
So how do we go about finding equivalent ratios? Well, very similar to fractions, we are going to use multiplication and division. And we're going to follow the principle that whatever we do to one number, we have to do the same to the other. So for example, I could multiply my 5 by 2, but then I would have to multiply the 10 by 2 as well. So let's do that. 5 times 2 is 10, and 10 times 2 is 20. So therefore, 10 to 20 would also be an equivalent ratio. Let's do it again this time, but let's times it by 3. And 5 times 3 is 15, 10 times 3 is 30. So 15/30ths is an equivalent ratio. But don't forget, I can also divide. But I have to make sure I divide both numbers by the same number. So essentially I'm looking for factors. And I can see that common factors of 5 and 10 would be 5. So I could divide both of these by 5. 5 divided by 5 is 1. And 10 divided by 5 is 2. So 1 to 2 is also an equivalent ratio. And actually 1 to 2 is also the simplified ratio, because that's it in its smallest form. Okay, let's have a look at question 2. 32/12. So I could times it by 2 and end up with 64/24, or I could times it by 100 and end up with 3200 to 1200. But again, I could also divide, and in this case I'm going to divide by 2 because I can see 2 is a common factor, and 32 divided by 2 is 16, 12 divided by 2 is 6. But this isn't yet our simplest form, because I can see they're both even, so I can divide them by 2 again, and I'd end up with 8 to 3. 8 to 3 cannot be simplified anymore, so this would be my simplest form, but also an equivalent ratio. Question 3, let's try and find equivalent fractions in our lists. So which of these ratios on the right is an equivalent ratio of 6 to 9? Well, let's look at A first of all. We can see that to get from 6 down to 2, I'd have to divide by 3. But if I divide my 9 by 3, I'm not going to get 5. So A is not an equivalent ratio. B is 4/9. Well, we can see straight away that can't be equivalent because we have a 9 here and a 9 here, but then our first numbers are different, not equivalent. 2, 3. Okay, this looks a bit promising. To get from 6 down to a 2, we would divide by 3, and if we divided my 9 by 3, I would get 3. So 2 to 3 is an equivalent ratio. What about 6 to 30ths? Well, for exactly the same reason as B, can't be because we've got a 6 at the start and a different number at the end. Not equivalent. What about question 4? 4/8. Well, I can see already that 4/8 is 1/2 because 4 is half of 8. So B, I know, is going to be an equivalent ratio. But what about A? A is also an equivalent because 5 is half of 10. But C is not equivalent and D is also not equivalent. So there you go, that is finding equivalent ratios. Things to remember, equivalent ratios are similar to equivalent fractions. We can use times and divide to help us, but what we do to one value, we must do to the other. Okay, here are 4 questions for you to have a go at, same as the style that we worked on before. Have a go at answering them, put your answers in the comment section.
Okay, another really key part is looking at how to simplify ratios. So let's learn how to do that. You know what to do, let's go.
Okay, we're going to have a look at these 4 questions here today, but first let's just remind ourselves what simplifying a ratio actually means. So if we look at this first example, we have 5 to 10, meaning that we have 5 of one thing to 10 of something else. Now this could be apples to oranges, cars to boats, absolutely anything. But essentially what it's saying is that for every 5, we have 10 of something else. But this might not be its simplified form. And in fact, if we look at this one, what I can actually do is I could say that for every 1, we have 2 of the other. We can just check that that works with them all. 1 here, pairs to 2. 1 here, pairs to 2. 1 here, pairs to 2. And finally our last one also pairs to 2. So our simplified ratio would be 1 to 2. But as we know, it's not always convenient to draw pictures, so we need another method. And what we can also know by now is that ratio is very similar to fractions. 5 to 10 is the same as saying 5 over 10. And what we know about fractions is that to simplify, what we must do to the top number, our numerator, we must do to the denominator. And essentially what we're looking for here is the highest common factor of these two numbers. And I know that the highest common factor of 5 and 10 is 5. So I can divide my 5 by 5, which leaves me with 1, and then I can divide my 10 by 5, leaving me with 2. Therefore my simplified fraction is 1 over 2, and therefore my simplified ratio is 1 to 2, just like we proved before. Okay, let's have a look at question 2, just using the written method now. So my ratio at the moment is 4 to 12. Well, again, I'm going to look for my highest common factor, and the highest common factor of 4 and 12 is 4. So if I divide my 4 by 4, I'll be left with 1, and if I divide my 12 by 4, I'll be left with 3. So 4 to 12 is equivalent to 1 to 3, but 1 to 3 is its simplest form. Let's just double check that with the fraction version, which would be 4 over 12. 4 over 12, 4 divided by 4 is 1, and 12 divided by 4 is 3. 1 over 3 is the same as saying 1 to 3. Question 3 now. We have 20 to 15. So again, just looking for that highest common factor, and the highest common factor of 20 and 15 is 5. Therefore 20 divided by 5 is 4, and 15 divided by 5 is 3. So 20 to 15 is equivalent of saying 4 to 3. Question 4 looks a little different, and the question is going to be, what is the ratio of apples to oranges? Well, let's quickly find out what the ratio is to start with, and we have 1, 2, 3 apples, and 1, 2, 3, 4, 5, 6, 7, 8, 9 oranges. Therefore my ratio is 3 to 9. But is that its simplest form? No, because I can see a common factor of 3, and 3 divided by 3 is 1, 9 divided by 3 is 3. So we have 1 to 3. And we can just double check that by making sure that for every 1 apple, we have 3 oranges. For every 1 apple, we have 3 oranges. And for every 1 apple, we have 3 oranges. So we know we're correct. And there you go. That is everything you need to know about simplifying ratios. Remember, simplifying ratios is similar to simplifying fractions. We first find the highest common factor, and then we use this to divide our numbers by to find the simplified form. Here are 4 questions for you to have a little look at. Same format as before. Put your answers in the comment section. Press pause on the video now. Good luck.
Okay, so those little skills that we've just learned about ratios should now let us find missing values in our ratios. So let's use all the prior knowledge to master this little part of the lesson. Let's go.
And to do that, we're going to follow these 3 steps. First, we're going to find the connection, which means find the connection between the 2 sets of ratios. Then we're going to use multiplication or division to help us. And then step 3, what we do to one of the numbers, we must then do to the other. So let's see what that means. So let's have a look at question 1, and we are trying to find the value of this x between these 2 equivalent ratios. And step 1 says to find the connection. So what does that mean? Well, it means that if these are equivalent, then the 2 sets of numbers that we have will have some sort of connection. And obviously with a ratio, the order that the numbers are written is really important. So this 10 is paired with this 30. So what we're looking for is the connection between it. And to do that, we're going to look at step 2, the multiplication or division. So I can see that to get from 10 to 30, I would need to multiply by 3. Or the opposite way around, if I wanted to get from 30 to 10, I could divide by 3. But because our missing ratio is on this right hand side, we're going to have to times. Then step 3 says whatever I do to one of the numbers, I must do to the other. So if we multiplied the second digit by 3, therefore we have to multiply the first digit by 3 to get the equivalent ratio. So if I was to multiply my 5 times 3, I would end up with 15. So therefore x equals 15. Let's quickly look at this in another way. And we know that ratios are very closely linked to fractions. So 5 to 10 is actually the same as saying 5 over 10 equals x over 30. And again, when finding equivalent fractions, we know that to get from 10 to 30, we'd need to times by 3. So therefore, I need to do the same to the numerator, times it by 3. 5 times 3 is 15. Same answer. Okay, let's look at question 2. And again, we're looking for that connection. So this time we've been given the value of the first number in each of the ratios. We have an 8 and a 4. So how do I get my 8 to be a 4? Well, I would have to divide by 2. And if I divide our first number in our ratio by 2, therefore I have to divide the second number 2. So 12 divided by 2 is 6. And therefore x equals 6 in this second example. Let's jump to number 3. Number 3 says 2 to 9 and 8 to x. So again, I'm looking for that connection. We've been given the first number in each of the ratio. So I'm looking at how to get from this 2 to an 8. And we can see that to get from 2 to 8, I would need to times by 4. So therefore, if we're timesing the first number in the ratios by 4, we would also need to times the second number in the ratio by 4. And 9 times 4 is 36. So in this case, x equals 36. So 2 to 9 is equivalent to 8 to 36. Let's look at our last one. 5 to 15 is equivalent to x to 3. Now let's find the connection. Well, we've been given the second number in each ratio. I have a 15 and a 3. How do I get from 15 to 3? Well, I'd need to divide by 5. If I'm dividing the second digit by 5, I then need to divide the first one by 5. So 5 divided by 5 equals 1. So in this last case, x equals 1. Pretty straightforward, right? Let's look at what to remember. Ratios are similar to fractions. First, find the connection between the numbers we know, whether it's the first or the second digit of the ratio. Then we're going to use multiplication or division to establish how to get from one number to the other. And then we're going to use this same operation to the unknown pairs of our ratios. Now it's your turn. Have a go at answering these 4 questions. Press pause on the video now Take your time and put your answers in the comment section. Good luck.
Okay, ratio's done. Now the final part of our big lesson today is we're going to look at how to find the percent of a given number. It's the final part of our lesson, guys, so strap in and make the most of it. Let's go.
Hello and welcome back. Today we're going to be looking at how to get the percentage of a number. And we're going to start by looking at this first question that says 20% of 85. Now before we get into the method at the top here without the use of a calculator, let's just look at what we would press with a calculator. And if we pressed 85 multiplied by 20%, we would end up getting our answer, which is 17. But we're not using a calculator today. We're going to look at the written method. So first we're going to divide by 100. Then we're going to multiply this by the percentage value. And then we're going to look to see if there's any shortcuts that we could have found. So let's see what that means. Well, first of all, what we have to understand is that at the moment, 85 equals 100%. So what we could do is find 1% and then use that to multiply it by the 20 to get our 20%. And how are we going to get 1% of 85? Well, we can simply divide it by 100. And 85 divided by 100 gives us 0.85. We can do that just using our place value knowledge, or if we needed to, we could use our bus stop by simply putting 85 inside and 100 outside. So how many hundreds into 85? We get 0, put a decimal, carry our 85 across. How many hundreds in 850? We have 8 with 50 left over. Put another decimal and our 50. How many 100s in 500? We get 5. So we get 0.85. And now what we've just found is 1%. So this 0.85 actually is the value of 1% of 85. But we're looking for 20%. So now if I simply get my 0.85 and I times it by 20, I will end up with the answer 17. How could I do that with my written method? Well, simple multiplication. Ignore the decimal for now and just do 85 times 20. 0 times 5 is 0. 0 times 8 is 0. Put back my placeholder. 2 times 5 is 10. 2 times 8 is 16, plus my 1, 17. Add them up, I get 1700. But remember, we were timesing by a decimal, and there was 2 digits after my decimal. 1, 2. So I'd come in 1, 2 with my decimal, put it in place, 17. And that's the best way to do it. Find that 1% and then times it by the percentage that you need. But maybe there is a shortcut and we can use our number knowledge. So 20% of 85, what I could say is 10% is quite easy to work out, equals 8.5. So therefore 20% is 2 times 8.5, which is 17. So I could use my number knowledge if I've got it. Okay, let's have a look at the next one. I've got 36% of £250. So I can understand that 250 equals my 100%. So therefore, 250 divided by 100 equals 1%. And 250 divided by 100 is 2.5. Again, if I needed to, I could use my bus stop. I'm not going to do it now because I can see that in my head. So 2.5 equals 1%. But I'm looking for 36%, so I'm going to times my 2.5 times 36. And again, I'm going to try and use some mental maths, and I'm going to just do 2 times 36. 2 times 36 is 72. And then I'll do 0.5 times 36. And 0.5 times 36 is just half of 36, which equals 18. Add the two together. 72 add 18 equals 90. 36% of 250 is £90. Simple. Let's just focus on what to remember. First, we're going to try and find 1%, and we're going to do that by dividing by 100. Then we can multiply this number by the percentage value we're looking for to get the percent we want. And remember, always look for some shortcuts, relying on some number knowledge that you might have. Okay, here are 2 questions for you to have a little look at. Take your time, press pause on the video and put your answers in the comment section.
And there you go, guys. That is everything you need to know about ratio, proportions and statistics in year 6. Master this and you're going to have no problems with your year 6 SATs when it comes to these elements. But remember, this was only unit 5. Do check out all the other units covering everything you need to know in year 6 for maths. So with that in mind, hopefully I'll see you in another video. But for now, guys, peace out.